By 2026, concerns over privacy and the rising costs of API tokens have made local AI a strict requirement for many professionals. To keep your data private and your cost predictable, you have to run these models on your own hardware. But building an entry-level system presents a choice between two very different priorities. For roughly $250, you have to decide, do you prioritize the speed of a modern architecture or the memory capacity of an older one? These are the three primary contenders for local work in 2026. The new RTX 5050 offers 8 GB of VRAM for $249. On the used market, the older RTX 3060 provides 12 GB for nearly the same price. And for those expanding their budget to $700, the used RTX 3090 offers 24 GB. Selecting between them requires a shift in how you think about hardware. In local AI, compute speed only determines how quickly a task finishes. Memory capacity, your VRAM, dictates whether that task can even start. Marketing materials for new cards focus almost exclusively on generation speed. However, if your specific workflow needs 10 GB of space to run, a card with only 8 GB of memory will never reach those advertised speeds. You can end up paying for a level of performance that the hardware's own capacity prevents you from using. The RTX 5050 is built on the Blackwell architecture, which introduces native hardware support for a quantization format called NVFP4. This format mathematically shrinks the memory footprint of a model by 3.5 times compared to standard precision. It allows a relatively small card to hold larger models than previous architectures could manage at the same size. This chart shows the resulting throughput advantage. By using native NVFP4, the RTX 5050 can generate over 91 tokens per second. The older 3060, using standard software quantization, generates fewer than 26 tokens per second in the same scenario. This is a significant efficiency gain, but it is entirely dependent on the workload remaining within the card's 8 GB physical limit. When you are running a single lightweight model for basic chat, the 5050's throughput is excellent. But once your workflow grows in complexity, that 8 GB buffer creates a mechanical bottleneck that raw compute speed cannot solve. Professional visual generation in 2026 has moved past simple text prompts. Creators now use node-based frameworks like ComfyUI to link multiple models together, allowing for precise control over the final image. A typical professional pipeline requires loading the base model weights, a text encoder, and style modifiers called LLMs. Every one of these components needs a dedicated slice of your GPU's memory to function. This diagram illustrates exactly when the system fails. Adding a control net pushes memory demand past 11 GB, instantly exhausting the RTX 5050's 8 GB buffer. The system then initiates a PCIe swap, offloading data to much slower system RAM to prevent crashing. This swap introduces massive latency. A generation process that should take 15 seconds on a capable card can stretch into over an hour when the system is forced to move data back and forth across the PCIe bus. The older RTX 3060 avoids this failure entirely. Its extra 4 GB of memory hold the entire pipeline locally. Even with a slower processor, it finishes in minutes while the 5050 struggles with the memory swap. There is also a qualitative cost. Squeezing these models into 8 GB requires aggressive compression that strips away the mathematical precision needed for complex textures. This is why generations on low VRAM cards often look smoothed or plasticky compared to higher precision outputs. For complex visual aesthetics at the $250 price point, the RTX 3060 is the more effective tool. Having enough memory to complete the task is more valuable than having a faster core that cannot finish it. Programming tasks face a similar wall. Professional coding assistance requires loading mixture of experts models, which are designed to handle complex reasoning across large code bases. Even when heavily compressed, the weights for a 14 billion parameter coding model consume about 6.5 GB of VRAM. To actually read your code, the AI uses a key value cache. This is where it stores every line of code and documentation you provide. The size of your VRAM determines how many lines of code the model can keep in its memory at once. When we compare the memory remaining for this cache, the gap is wide. On the 8 GB 5050, you are left with just 700 megabytes of space. On the 12 GB 3060, you have 3.7 GB of runway. That 700 megabyte limit restricts the AI to about 4,000 tokens, barely enough to understand a single file. The 3.7 gigabyte buffer on the 3060 accommodates over 32,000 tokens, allowing the model to analyze entire project directories without losing context. A model generating code at high speed is useless if it lacks the memory to read the files it is debugging. Choosing the right hardware is about matching your specific tasks to the physical limits of the silicon. This matrix maps our 3 primary GPUs against real-world AI viability. The RTX 5050 is a strong choice for casual users. If you run basic chat models and simple image prompts, its modern speed makes it a solid $249 investment. If you are a practitioner working on a $250 budget, the used RTX 3060 12GB is the better choice. It provides the memory capacity required to run professional ComfyUI pipelines and handle large coding contexts that would overwhelm an 8GB card. For those who need uncompromised performance, the used RTX 3090 remains the gold standard. Stretching the budget to $700 gives you 24 gigabytes of VRAM, which handles massive 100,000 token windows and the highest quality image generation without compromise. In the 2026 landscape of localized AI, compute speed is a luxury, but memory is a requirement. Secure the VRAM capacity you need to run your workflow before paying for speed you might not be able to use.